Hey everyone, it's Mr. Canfield. Today we're going to be doing chapter 1.5, solving inequalities. So we're going to stretch this out because there are some, the book goes into some pretty intense problems, and I want to make sure that we get the basics before we go into the intense ones. So there are 10 problems in this video, and with these 10 problems, if you get them all, great, and you are welcome to pause the video, write the problems down, do them on your own, and if you just want to check my answers, I'll have my answers on screen at the very end of the video. So here are the first, 4 that you can see on the screen right now. So feel free to pause and to do them. And then here are 5 and 6, feel free to pause and do them. And then here's 7, 8, 9, and 10. Feel free to pause and do them. I'm going to go through and do each of these with explanation. But if you want to go through and try them all, you are more than welcome to. Some people said I go too slow. All right. So, number 1. So if I'm trying to write the solution to an inequality like this, if x is by itself, then the work is already done. But we now have to know where on the number line does this sit. And so we know, well, if we said this is 0, 1, 2, 3, we know that 3 is going to be involved. And when we graph solutions to these, you might remember this, you might not, from previous years, we use either a circle or a filled in dot. And what the circle represents is we go all the way up to 3, but we're not actually 3. And so we look at this and we see x and then that thingy and 3. And we have to determine, are we allowed to be 3 or are we not allowed to be 3? So that's really going to be, do I fill this in, do I not fill this in? It's going to come down to what that means. And then the other thing is, am I shading to the left of it or am I shading to the right of it? Well, to the left of it is anything that's less than it. To the right of it is anything that's greater than it. So one way that we can figure this out, even if we forget the names of these, we can figure this out by going, well, it's a mouth, right? And the mouth always eats the bigger one. Well, I can pick any number on either side. Like I could pick 2, right? I could try 2 for x. Is the number currently eating the bigger number? Sorry, is the mouth currently eating the bigger number? And sure enough, the mouth is eating the greater number of the 2. So we know that 2 is good. 2 would be in our shaded region. And so we don't have to go through and check every number over here. We know that since one number over here works, they all do. Don't believe me? Pick any other number over here. Negative 53, is that less than 3? Yes, it is. 3 is the greater number here. So because of that, we know we're going to shade this side. And I actually draw the arrow showing it's any number over here is good. Now what about over here? What if I picked 4? This mouth is a sad mouth because it's supposed to be eating the greater of the 2 numbers. And it doesn't get to. So he's sad. He's excited, he's sad because this is wrong. So we don't shade over there. Now, is it a filled in dot or is it an open dot? Are we allowed to equal 3? And that comes from the line underneath. If the line is underneath, that means you can be 3. The cool thing is the line also kind of tells us, is there coloring in or is there not coloring in? So like if we saw this or we saw this, yeah, write the same one both times, Canfield, good job. If we see either one of these, the line underneath tells us it's filled in. Since there's no line underneath, it's not filled in. Okay. And again, that's because, well, is 3 part of our answer? The mouth doesn't know what to do here. It could eat either of these. They're the same. So this doesn't work. But if there was the line underneath, then we'd be good. Okay, so that's number one. Number two. All right, so my answer for number one is going to be boom, boom, boom. Here's 3, open circle to the left. All right. So number two. So everything's the same, but we can go a little bit faster now, right? We have -2. That's going to be what we're focusing. That line underneath tells us we're filled in. And then we need to figure out which side this belongs on. And so I can test any number I want. I could test 0 if I want. Is 0 greater than or equal to -2? And remember, negative numbers are less than positive numbers, and they're less than 0. So yes, that is true. So we can shade over here. So boom, I can shade over on that side. But let's say you weren't sure. Well, try -10. Is -10 greater than or equal to -2? That was some random number I picked over on this side. Remember, 10 is greater than 2, but -10 is farther down on the left-hand side. It's less than -2. So there is a trick. Here's the trick. X must be on the left. If X is on the left, then the inequality symbol is an arrow. It actually points the direction that we shade. So for either of these, this would be open circle going that way. This would be closed circle going that way. This would be open circle going that way. This would be closed circle going that way. If X is not on the left, then the direction it goes is reversed. The little trick doesn't work anymore. So it's not actually an arrow. That's just a helpful memory device. So if I were you, I would have paused the video back there and written that down, because that's a really, really useful trick as long as X is on the left-hand side. You can make it look like you're doing math in a flash. Sorry for Maeve in the background. She's just having a good time. Yeah. All right. So number 3. Now we bring in solving moves that we have to do to these. The good news is it's the exact same as it used to be with equations. There's one subtle difference. We won't get to that till number 6, though. Until then, it is exactly the same as solving regular equations. So if this was an equation, we draw the line down the middle. We just subtract 1 from both sides, and we get X is less than or equal to 4. Now that we're here, all we've got to do is graph our solution like we were just doing. So in this case, we've got our number line. We're at 4. The line underneath tells me it's a filled in dot, and I see it's going to the left. It's less. So, and that's also the direction our arrow is pointing. So I know I'm going a little quick, but I just want to remind you, you are always welcome to pause the video, and if I don't make sense, feel free to talk to me about it. Feel free to ask me about it. All right, let's see. I'm not going to start a new page. I'm just going to flip this one upside down. All right, number 4. X minus 4 is greater than or equal to -1. All right. So again, it works the same way as it used to. We just use regular solving moves. Add 4, boom. We get X is greater than or equal to -1 plus 4. You can use your calculator if you're not sure, but that's 3. And so when I go to graph this, I know that we're going to be at 3. We're going to have a filled in dot because of the line underneath, and we're going to the right. Okay. Then we reach number 5. It says 8x is equal to 4. No, it doesn't. It says 8x is less than 4. Oh, hey, if you ever want to know how to read these, an easy way to read them is to throw to throw this in here, right? Which way does the symbol belong here? Well, it always eats the bigger one, right? So it belongs going this way. And I know that 4 is what, 6? You know, use your common sense. You know that 4 is smaller than 6. 4 is less than 6. So this is a less than sign. The line underneath says or equal to. So less than or equal to 6. So let's try it again. Let's 10 and 2. So, well, we know the mouth eats the bigger one. 10's the bigger one. And so now I can say 10 is than 2. 10's the bigger one, right? So 10 is greater than 2. That's how I remember how to read these, honestly. If I ever forget, I'm like, I just kind of picture a situation with 2 random numbers, and I go, which way does the mouth go? Oh, right, that means that it's this way. All right. Oh, yeah, I was going to actually do number 5. So number 5 says 8x is less than 4. Notice how I put it, I should have been put, yeah, I put a number next to whatever problem I'm working on. Make sure you're doing that. If you don't put a number next to what you're working on, then later when you're trying, if you ever have to go back and recopy something or you ever have to turn it into your teacher, no one's going to know what number you're working on. So here, well, it says 8x is less than 4. So the way that we would solve something like this before, well, this was times, right? So we're going to divide by 8, divide by 8. X is, now let's say you don't know what 4 over 8 is. Our calculator can simplify this. This is going to be a fraction. Oh, maybe. She crawled across the room, and I was helping her back, and she's like, I don't want to go back. I want to stay across the room. Oof, that was a noisy bump. All right, so let's say we're not sure what 4 divided by 8 is. All you gotta do is grab your calculator, and on your calculator, type 4 divided by 8. When you hit enter, now, okay, I know what 0.5 is. You probably know what 0.5 is, but let's say you don't. Let's say you just, you don't know what decimal that is. If you hit the math button here, this very first option, frac, you hit that, boom, it says ANS, that means answer. Turn the answer I just got into a fraction, boom. It'll tell you that it's a half. So you're always welcome to do that. So quick, oh, so we get less than 1/2. So on our number line, here's 0, here's 1. We know our answer is going to be here at 1/2. And it's open because there's no line underneath, and I see it's going to the left. All right. So real quick, let's just test ourselves really quick. If we had 60 over 100, try doing that and converting that to a fraction. That should convert to 3 over 5. If you can get 60 over 100 to 3 over 5 using your calculator, you know how to change it. So, good job. So let's see, 5 was x is less than 1/2. A big part of these answers is the graphs. If you don't do the graphs, guess what? You didn't answer the question. Every year I have students who don't do the graphs, and I'm like, dude, why do you think I was doing them in class? Oh, you probably thought I was doing them for fun because I just felt like doing it. Maeve's like, what are you talking about? All right, so here is the one situation where things are different. When we divide by -2, That is our special trigger. When you divide by a negative, the sign flips around. Every time. So that is our one special trick, one special thing to make sure we get. And it's only when the number that's touching x is a negative. It's not over on the other side. Like if this had been 2x is less than negative 12, and we divided it, that number that I'm dividing by is not negative, so it stays. The only time it changes is when the number touching x is a negative. Make sure you write something down about that. That's our one weird special thing about these that's different. So divide by a negative, flip the symbol. A lot of people say flip the sign. It sounds nicer. Totally fine with that. Oh, I got to graph my answer too, right? So I know I'm going to be here at -6, open circle because of that. Boom, to the left. Hopefully these graphing things are starting to work out for you all right. Okay, got 4 more. Oh, wait, I didn't write my answer on my answer sheet. I said at the very end I was going to have all the answers just sitting there so people could check. All right, so can you tell this video is rushed? I'm trying to make this a brief video, not 45 minutes long. So we are actually almost done. So a lot of people struggled with these two-step equations. I just want to remind you, you do one, then you do the other. So the first thing we do is any adding or subtracting. So I do that +5 first. And the way we get rid of it is with a -5. So 3 minus 5, I can use my calculator if I'm not sure. 3 minus 5 is -2. So now I got the 2x left over, and I'm going to be dividing by this 2. Is that negative? No. So we don't flip the sign. It doesn't matter that that's negative over there. It matters that this is negative. So I get x is less than -1. So with x less than -1, then when we go to graph it, we got an open circle at -1, and we go whoosh, right? All right. Don't hate number 8. So let's see. We're going to do our regular solve moves, right? I use pluses and minuses first. So I see that +1. I'm going to subtract it from both sides. Get negative forks. Over here, I got 13 minus 1. I get 12. When I divide by -4, I divide by -4. Hey, we're dividing by a negative this time, right? That means we take that sign and we flip it around. So 12 divided by -4, you can type in your calculator if you don't know, you get -3. So you know x is less than or equal to -3, you go bap, bap. Oh man, here's our -3. There's our circle. Oh wait, it's got a line under it. It's filled in, wow, filled in circle. Then we gotta figure out which way to go. Well, it says less than, right? We go to the left, to the less, left, less, L. Take the L. All right, so x is less than or equal to -3. And we go bippity boppity boop whoop. All right. 2 more. 2 more problems. 2 more problems. I don't know why I included number 9. Oh, I know why I included number 9. 3 plus 6x less than or equal to 15. All right. So, trying to get x by itself, I do pluses and minuses first. I see this 3 over here. This 3 right now, it's positive because of the thing on the front of it. So I'm going to subtract 3, gone, right? Now, what kind of 6 is left? It's a plus. It's a positive 6. So 6x is left over. Boom. 15 minus 3, that's 12. Divide both sides by 6. Divide both sides by 6. Is that a negative? No, it's not a negative. So it's gone. We get x less than or equal to 2. Done. It's almost like there's a pattern to these. It's like you always do the pluses or minuses first. And then you divide. 2. All right, open circle. No, it's not. It's got a line underneath. Closed circle to the left. All right, so we got x less than or equal to 2. So we go back, 2. All right, final round. Okay, number 10. Last question of the lesson. Lots of negative symbols. It's like he's trying to mess with us or something. Negative 7 minus 4x greater than 17. Okay. So I see that negative 7. I can ignore that. Since it's negative, since I'm doing plus or minus moves, I do plus, right? 17 plus 7, last time I checked, is 24. Now what's over here on this side? See how there was a minus in front of that? This is still going to be negative 4x. So now when I try to get x by itself and I divide by negative 4, dividing by a negative. What's that do? Flips the sign. 24 divided by 4, oh wait, negative 4. Well, 24 divided by 4 is 6, right? And then a positive divided by a negative is a negative. So negative 6. Here's negative 6 on our number line. Open circle, yep, stays open. And then whee, this way. Ladies and gentlemen, I hope that was helpful. If it was not, you know where to find me. And please don't just go, I'm never gonna get it, I'm an idiot. No, you're not. If you don't get it yet, let's focus on that word. I don't get it yet. And you probably at least get some of it. Now he's gotta find my first page. There, nope. Where did it go? Hello? Where are my other problems? I need to have all my answers on the screen at the same time. I promised I would do that. I don't know why I'm talking like this. It couldn't possibly be because I'm stressed about getting this uploaded in time. I totally didn't film this the day of class. I filmed this before. Okay, let's see. Now we just got to get everything on screen at the same time. So, I'm going to hold this here for approximately, 30 more seconds. So, here are all of my different answers. If you think I made a mistake somewhere, feel free to let me know. Feel free to ask about it. It's possible. I do make mistakes. Don't know if you've ever had a math teacher tell you that before, but we all do. Everybody makes mistakes. So don't feel bad if you didn't get them all right. But if you have any questions about them, I would love to help you. Remember, just because you have all the right answers written down doesn't mean you understand it. And just because some of your answers are wrong doesn't mean that you don't understand it. Seriously. Okay. Hope that was helpful. Bye.